All right, so before we get to like all of our conic sections, which requires us to do a lot of graphing, part of it is about binomials. And so we've got these rules we've been using. All right. So we have like a plus b quantity squared. All right, these are the ones that were up on the board that we've been doing with radicals also. All right, so this is our rule. All right. And it's a way of being able to expand out like a binomial square. So like if you have your two terms and it's a quantity being squared, you can expand it out this way. If we go from the right-hand side to the left-hand side, then that's factoring. All right, so this is going that direction. So it's the same thing if I put a minus sign in between there. All right. So again, a lot of our goal when we are going to be dealing with these equations with conic sections is to move backwards to be able to figure out what the binomial square looks like. Right. So we're just going to do a couple of them just so that way you can kind of get the feel for it. Again, this part right here is going to be review, and then I'm going to do the new technique. So your factoring that we've been doing would be something like, I don't know, x squared plus 18x plus 81. And so I want to be able to take this trinomial, which looks like one of these two, and rewrite it as a binomial square. Right? So the easiest thing to do is just to make sure it matches the rule. Right? So first one is squared, last one is squared, and so you're just checking to see if this is going to be 2 times the middle. So this is really how I check it, is I just start with saying, is this how it looks? Right? So the square, if I square both of these two, and then 2 times the product, if it gives me that middle term, then it's factored correctly. So you're really just looking at taking the square root of 81 and multiplying it times 2 and seeing if that's the coefficient of the middle. It doesn't matter what variable is there. And so like y squared minus 12y plus 36. So because there's a minus sign in here, now it's going to follow the pattern of the one with the subtraction sign. And so I'm just going to take the square root of 36 and see, is that true? And so again, if I multiply 2 times 6, or sorry, negative 2 times 6, I get that middle term. So this is really what you're checking, is you're trying to be sure that it works this way. Right. And it works the same when you have a number in front of the x squared term. All right, so middle term is positive, so your binomials are going to be separated by positives. And if I take the square root of the first term, I'm going to get 2x. Square root of the last term is 3. And then I'm just checking if 2 times 2 times 3 is this middle term. And so that would be factored correctly. And so what we want to be able to do is we want to be able to write binomial squares so that way we can do our graphing, because when we graph like circles and everything else, a piece of the binomial is going to tell us like where the center of the graph is. Right. And so this is what we call completing the square. Right. And so with completing the square is you're trying to create that binomial square. And so this is really where we want to focus most of our attention, because this is the work you're going to be doing like more often with the conics. So if you have like m squared minus 6m, right, that's only 2 terms. So what I'm trying to figure out is what do I need to add to this to be able to write it like that. So now I have to actually add something to this binomial to make it a perfect square. And so because your middle term here is always 2 times the product, right, I want to go backwards, and I want to take this middle term and say, cut it in half, and then square it. When I cut this thing in half and then square it, that's what I'm going to add to make this work. Right? And so I just have to think about, because even though I'm squaring it to get this binomial, the thing that's going to have to go here is what it looked like before I squared it. And so just double check it. Just see that if that's going to work, that if I square the first 2 times the product and square the last, you actually get that trinomial right there. And so this is going to be your process. Take half and square it. And that's what you're going to add. So we'll do a few. So like x squared plus 20x. You're always adding something. If you look at the rules that are up here, your last term is always adding something squared. So I'm still going to be adding something, and like in this one, because there's a plus sign here, I'm going to want to write it like this. So again, you're just going to take this number in the middle and cut it in half. When I square it, that's what I'm going to have to add. But again, the number that I have as my base before it's squared. Think about this as the b that's being squared. I just want the number itself when I'm creating the binomial. Most of the time when I ask you to check it, I just want you to do a mental check that the expansion actually works. I don't know. Let's see, like minus 3. The easier ones are the ones that are evens, because when you cut something in half, you get an even number. Odd ones are a little weird, because if you take a number and cut it in half, you're not going to write that as a decimal. You're going to say, this is the number cut in half. I still have to square. So you're going to be adding 9/4. This is going to be a little bit weird, but the same thing. This inside the parentheses is my b that I just squared. That's the number that's going to go in here. And the reason why we need to focus on these weird ones that are odds is because, again, like when I have to graph a coordinate, I can graph something that's like a decimal. What's up? So if I actually expand this out right here, you're always thinking about, it's always in your rule, it's going to be square the first, 2 times the product, and square the last. And so I need to make this number right here, whatever is going to be that when I square it, because it's a fraction, I'd be squaring the top and the bottom. I have to kind of be able to work my way backwards. So when you have oddball ones like this, it's harder, just because you're left with a fraction, not like an integer value. Like these ones up here, when I take this term, cut it in half, I have like an integer value that I'm still squaring. You're just going to do the same process, even though it seems kind of weird with a fraction. So like if I put like, say like a 5 here, right? When it's odd, what it's going to happen is it's going to create a fraction that when we plot coordinates, you're going to be plotting like decimal coordinates. Yeah, so I still want to be able to say I have to add something. Right? But same thing, if this is what I'm cutting in half, I just don't get a number. Like on here, when I cut something in half, I was able to simplify that down first before I squared it. I can't do that. So this right here is going to end up being my b value. But to figure out what I have to add, I have to square it. So whatever you actually cut in half becomes your b value. Once you square it, that's what you're adding. Right? So every single time, like this right here, the 3 is my b value that I then squared. So if you have something even in the middle, you're going to have an integer value as your b value. If you had an odd number in the middle, you're going to have a fraction as your b value. And so this is really all we're doing today. Like, because when we do some graphing tomorrow, we're going to do this again, and I don't want to do the graphing of circles and this all at the same time.